Hey everybody, welcome back to a new video. In this video, we're going to be checking out one of the best budget options for a large power station. This is the FFpower P2001. Now this power station has lithium iron phosphate chemistry inside, so there's no fire risk, and you can get the full 2,000 life cycles, and after that you'll still have 80% of the original capacity, so a very long life with this power station. Now this has 2,000 watt hours of advertised capacity, and it has a 2,000 watt pure sine wave inverter, meaning you could basically plug in any household appliance to this and it's not going to have any issues powering it. Now what's nice is this also supports UPS functionality. Now this comes in at a price of $1,500 on sale, which is very affordable for what you get. There are other power stations that are more expensive, and in this video we're going to be doing extensive testing and put it through my new power station grading system so we can see how this compares to the competition at the end of the video. Now I actually did take this on a camping trip to see how it would perform, and I had my IceCo VL60 Pro plugged into the DC output on a 5-day camping trip, and at the end of the trip this was still sitting at about 25 to 30%. I can't remember the exact amount, but during that whole time I didn't have to charge it once. So this makes a great option for powering a DC appliance because it has a very low parasitic drain on the DC output, and with so much capacity you can run a fridge basically forever. Just plug in solar panels and you're good to go. Now let's go ahead and jump into the testing on this power station. Let's go ahead and start with the DC output. Now taking a closer look at the DC output, you have a power button on the bottom. It turns it on and off. You have a nice LED light that is illuminated. You have two 5521 barrel connections, and then you have two dust covers. Under one of them is a 12-volt cigarette plug, and under the other is an XT60 connection. Now I always like to test the level of regulation, so I plugged in my battery load tester, and this is actually regulated at 13.2 volts throughout the entire state of charge. Now to test the maximum power that I could pull from each of these outputs, I plugged in my battery load tester. On the 5521 barrel connection, I was able to get a little bit under 100 watts. And then plugging the battery load tester into the 12-volt cigarette plug, I was able to pull 197 watts before it shut off. And on the XT60 connection, it was very similar at 197 watts. Now I wanted to test plugging in two battery load testers, so I plugged them both into the cigarette plug and the XT60 connection at the same time, and I was able to pull 223 watts before it shut off, which was really good. Now the last little test I like to run on the DC output is to plug in a DC powered air pump. These pull a ton of surge current and a lot of wattage, and a lot of power stations can't handle this. So here's the footage of me trying to run it on the power station. So as you can see, it didn't have any issues while running that air compressor, so very good results on all the testing on this DC output. Now I decided to put the power station DC output to the test by connecting up my IceCo Go20 12-volt compressor fridge to see how long it would run and if the DC output had any auto shut-off settings. Now I actually started this test on Thursday at 1:30 p.m. and now it is Sunday at 11:43 at night. So it actually ran for 82 hours and still has 13% left on the battery. Okay, so in the next test, I want to actually do a DC capacity test where I use my battery load tester, take this from 100% down to 0% and see how many watt hours we get out of the DC output. So let's go ahead and turn on the battery load tester. This is charged up to 100%. Let's start the test. Okay, so my battery load tester is set to 10 amps. We're getting about 13.2 volts from the DC output. Now we're tracking our watt hours here, and it's been going for a little over 5 minutes. Let's go until this hits 0%, and we'll see the amount of watt hours at the end of the test right here.
Many hours later.
Okay guys, the battery just hit 0% and the DC output just shut off. Let's go ahead and see how many watt hours we got through the discharge test. Okay, so we were able to pull 1,490 watt hours, and the test ran for 11 hours and 13 minutes, and it also pulled the equivalent of 112.9 amp hours. Now remember, this power station has an advertised capacity of 2,000 watt hours, and we only got 1,490. So let's take that 1,490 divided by 2,000, and that gives us 74.5% of the advertised capacity. So if you discharge this completely down using the DC output, expect somewhere around 1,500 watt hours or 74.5%. Now I always like to see at least 85%, and we definitely fell short on this test. Now this power station is great for charging mobile devices. There are quite a few USB options on the front. Now to turn on the USB ports, you just push the power button at the bottom. Then you have 2 regular USB-A ports, you have 2 quick charge USB-A ports, and then you have 2 100-watt USB-C power delivery ports. Now I was able to test all these USB ports by plugging in 2 power stations that each charged at 100 watts, and I also plugged in a USB fan and a USB light, let it all run for 20 minutes, and there were no issues running all these USB ports at the same time. Now let's go ahead and talk about some of the testing that I did on the AC inverter. Now just to recap, this has a 2000 watt pure sine wave inverter, and on the far side you have a flap that you can open up and it gives you access to 6 20 amp receptacles. You can basically plug in any device and go up to 2000 watts or a little bit higher. And I plugged in my oscilloscope to see what type of output we got on this power station. Now my oscilloscope did say that this had a pure sine wave output, which is great, right at 60 hertz. And I also was getting around 111 volts output, which is probably where you get your budget aspect of the inverter itself. Now, a high quality inverter will be putting out 120 volts, similar to your power company, but this one puts out 110 volts, so it is a little bit cheaper of an inverter. Now, there are a bunch of other tests that I like to run on the AC inverter, and the first one is an actual parasitic drain test. Now, if you leave the AC inverter on, it uses background power, and that will actually run the battery down even if you don't have a load on it at all. So that's called parasitic drain, and I wanted to test that on this power station. So I charged it up to 100% and I let it run for 2 hours. When I came back, it was only at 98%. So this power station has a very low parasitic drain, which is great when you have a small load running. That means that you can get a really long runtime because the inverter doesn't use that much power on the battery itself. Now, speaking of small loads, sometimes AC inverters will actually shut off if they don't have a load over 20 watts or so. So I actually plugged in a fan and let it run overnight. That fan was only pulling around 2 to 3 watts. And I came back in the morning and the fan was still running. So I don't see any issues running a small load on this AC inverter as well. Now sometimes AC inverters can also put out a little bit of noise. So if you're trying to run sensitive equipment, you'll hear that. So one way to test this is by plugging in a guitar amp to the AC inverter to see what it sounds like. So I plugged in my guitar amp and this is what it sounded like. Now I also plugged that same guitar amp into my wall outlet and this is what it sounded like there. So you can see both tests sound very similar. Now I'd say one of the most important tests that you can do on the AC inverter is probably a max load test where you put the max load on the AC inverter for 15 minutes to make sure it doesn't overheat or shut off. So what I did is I put a 2000 watt load on the AC inverter and tested running it for 15 minutes. Now during that I plugged in my oscilloscope. It was putting out a pure sine wave even under max load and the voltage was still at 110 volts, so no voltage drop. And it was able to run for 15 minutes without any problems. Now just beware that the fans will turn on full blast when you're running a max load for that long, and this is what the fan sounded like. Now 55 decibels isn't extremely loud. I've had power stations louder than that and I've had power stations less. So it's kind of right in the middle of the pack for sound volume with the fans running at full blast. Now one big feature that you get on this power station that a lot of other power stations don't offer is an actual UPS mode. Now that UPS mode is basically a battery backup for a device that you have on grid. For example, if you had a home office and the power goes out frequently, what you could do is you could have this plugged into your wall outlet and then you could have your home office powering off all the ports on the side of the inverter. And then if your power goes out, it instantaneously switches over to the internal batteries and you don't get a loss of power. Now this has the ability to support up to 1100 watts continuous through the UPS functionality. And the benefit to a UPS mode is that you're actually not cycling the batteries when it's charged to 100%. It's just passing power strictly through the power station to your load. For example, when I have this plugged in on UPS mode, I actually get 120 volts output because that's what my wall power is providing. But when it swaps over to its battery option and the inverter itself, like if the power goes out, it puts out 111 volts. So that's how you can tell when it's in UPS mode or if it's passing power straight through. Now I did test this with my studio lights and on a laptop that had its battery removed. And so what I did is I had everything plugged in on the wall and then I quickly unplugged it, you could see a very quick flash on the lights in my studio, and the laptop actually stayed powered on, even with its battery removed. So the swap over is pretty quick, and if you had a fridge running or your home office or any other load, you shouldn't even notice when it swaps over to the battery, except for that you have a small amount of voltage drop from 120 volts from your wall power down to 110 volts on the AC inverter. Now the last test that I want to do on the AC inverter of this power station is a complete discharge test. That means it's fully charged to 100%. We're going to take it all the way down until it shuts off, and we're going to track all the power going out of the power station through this watt meter so we can see how much usable power it has. So let's go ahead and start the test and kick off the time lapse. Okay, so we hit the end of the test. The power station hit 0%, the AC inverter shut off, and we were able to get 1,570 watt hours. Now, if you remember, this power station is rated at 2,000 watt hours. So in this test, we only got around 1,570, which is really short of the advertised capacity. In fact, if we take 1,570 divided by 2,000, that gives us 78.5% of the advertised capacity. Now, we've completed the testing for both the AC and DC discharge tests, and both of them we got around 1,500 watt hours. So what do you guys think? Should this be rated at 2,000 watt hours, or should it be rated at 1,500 watt hours? Let me know down in the comments below. Now, in the next portion of the video, I want to talk about charging up this power station. Now, there's a huge benefit to this power station, and it's that all the cables are included and have their own storage area on the top of the power station. So there's no additional clutter, you don't have to forget anything because all the cables fit up here, and there's no external charging bricks because this has built-in charging. Now, on the side of the power station, there is a flap that you can open up that reveals two charging inputs. You have an AC charging input and your DC to DC charging input, which handles solar panels and charging off another battery. This is an Anderson power pole connection, and I'll talk about that a little bit later here in the video. Now, there are 3 different cables included when wanting to charge up this power station. You get the AC charging cable, you get a DC to DC charging cable that has a 12 volt cigarette plug, and then you get your solar charging cable that comes with MC4 connections. And let's do a brief demo of each of those options. Now, the slowest way to charge this up would be using the DC to DC charging cable off another battery or your vehicle while you're driving, and you can get around 100 watts charging input. Now, that is mostly for topping off the battery and keeping it full while you're driving, because that's going to take around 20 hours to charge up the battery, and it's just very, very slow. Now, the next way to charge up is by actually using solar panels. You can get a total of 500 watts input on this power station, and let me tell you how you can do that. Now, this supports 12 to 48 volts input, so you have to do a combination of series and parallel connections to max out that connection if you're going to be using smaller solar panels. For example, if you wanted to purchase 6 100 watt panels for 600 watts total, what you could do is you would hook 3 of them in parallel, the other 3 in parallel, and then connect those 2 into series, giving you around 42 volts and 15 amps. So you'll see near the 500 watt charging input if you did that with 100 watt panels. And there are different panels that you can put together, but just make sure you don't ever go over 48 volts. And it's okay to go over 15 amps because the power station will limit the 15 amps automatically. Now, the last way to charge this up is by using the AC charging, which you could do off a generator or wall, and you get up to 1100 watts, and they call this the supercharge feature, and it'll charge it up in about 2 hours, which is very good. Now, what's even better is you can actually dual charge. You can dual charge off the DC input and the AC charging for a total of 1600 watts dual charging, so it charges up really, really fast. Now, let me go ahead and show you my solar setup outside where I can test the solar charging on this. We'll go outside and take a look at those panels and then see what charging input we get on the power station. Now, to test out the solar charging on the P2001, I'm going to be hooking it up to my portable solar array. Now, this has 4 180 watt solar panels, and they're currently connected together in series, so that's too high a voltage for the P2001. So what I'm going to be doing is I'm going to be taking 2 of them, putting them in series. I'm going to take these 2, put them in series, and then I'm going to connect those 2 sets into parallel so I can have around 45 volts and 500 watts. Now, as for the solar conditions today, it is around 85 degrees. It's sunny with just a little bit of high clouds,
And we are over paneling the setup, so we should still see 500 watts input, even though the conditions aren't perfect.
Now, having those panels plugged in, you can see we're getting around 475 watts charging input. Now, it's a little bit earlier in the morning, so we can't get perfect solar charging in on this. Now, I have seen 500 watts charging on this in the past, so it is possible. Just make sure you do a good combination of solar panels in series and parallel, and you will be able to hit the 500 watts charging input. Now, I also wanted to verify that this power station could handle pass-through charging, which means that you can use the power station and charge it at the same time. So I actually had dual charging plugged in at 1600 watts, and then I had a 300 watt load on the AC inverter and USB ports, and it handled everything just fine. Now I want to take a second to talk about some of the other details of this power station, starting with the weight. This comes in at 48 pounds, so it's actually not that heavy. It has two large handles on the top that make it really easy to carry around, and it has a slightly smaller footprint and is less weight than other 2000 watt hour power station. And that leads me to believe that it just has a little bit less battery capacity, because both of our battery capacity tests came out to be around 1500 watt hours, which is less than what I've seen with other power stations. So the weight kind of suggests that it doesn't have as many batteries as they kind of advertise it to have at 2000 watt hours. Now, looking at the display, it has a wonderful display. It tells you the watts input, your watts output. It tells you the battery percentage of the power station, and also gives you an estimated time remaining. And the display goes into a power saving mode after about 5 minutes to reduce the background power that the display uses. Now, there is an LED light on the front that has just a high mode, it has an SOS mode, and then a strobe mode. So if you ever needed to have a light in emergency, it's nice to have it built into the power station. And overall, it has a full ABS plastic design. It has two metal handles. It's fairly compact. I like the simple design. It's just a good looking power station, and it does perform well for the cost. Now, in the next portion of the video, we're gonna actually be putting this power station through my new power station grading system, and we can get the total score and compare it against the other competition to see if going for a budget power station is worth the cost savings. So let's go ahead and jump through all 10 points. Number 1, can this power station charge up to 100% in less than 4 hours? Yes, it can actually charge in about 2 hours using the AC charging input. Number 2, does this support pass-through charging? Yes, you can use the power station and charge it at the same time, no issues. Number 3, does this power station have a pure sine wave output? Well, during my testing, I plugged in my oscilloscope and we did get a pure sine wave output at 110 volts AC. Number 4, does this power station have a regulated DC output? Yes, the output is regulated at 13.2 volts through the whole state of charge, perfect for powering all your 12 volt appliances. Number 5, does this have an informational display? Yes, you can see everything you'd want to know on the display, and it works really well. Number 6, does this have any auto shut-off settings on the DC output? Well, through both my testing camping and in my house on my 12 volt compressor fridge, I was able to run it over 60 hours on each test without it shutting off. So no, this does not have any auto shut off settings on the DC output. Number 7, grading the USB output on this power station. Yes, it has USB-C. Yes, it has a 100 watt output, but no, it does not have a bidirectional USB-C 100 watt output. So it gets 0.66 points out of 1 point available. Number 8, this one's really important. Does this meet at least 85% of its advertised capacity? Well, in both of our capacity tests that we did on the DC output and AC output, this power station came up short and did not hit 85%, so we cannot give it a point in that category. Number 9, can this charge up to 100% in less than 5 hours using solar panels? Yes, because of the ability to charge at 500 watts solar, you can actually charge this up in around 4 hours using solar panels. And number 10, the last one, which is super important, where does this come in at price? Is it affordable at 80 cents a watt hour or less? Well, being a budget power station, this comes in at 75 cents per watt hour on discount, and I actually have an additional discount code down in the video description to bring the price down even lower, so it does get a point there. So if we tally up all these points, it comes out to be 8.66 points on the grading scale. So we have the opportunity to compare that to the other power stations. So I'll have a link down in the video description so you guys can check out my power station grading sheet and see how this one stacks up against the other 2000 watt hour power stations that I've tested. Okay guys, we're here at the end of the video. Thanks for sticking around. It's been a ton of information, but I thought it'd be helpful to give you guys kind of some pros and cons and final thoughts about the FFpower P2001 so you guys know how you could use this power station or what the best use case for this would be. So let's go ahead and talk about the things that I like about the power station. Well, I like the build quality, I like the display, I like that it has 200 watt USB-C outputs, I like that you can pull 200 plus watts out of the DC output and that it's regulated. I love that it charges fast off of AC charging, and the UPS functionality is really cool. I like that it has lithium iron phosphate chemistry, so you get the 2000 life cycles to 80%, and you don't have a fire risk when you're using this power station. Well, what are some things that I think could be improved or that I don't like? Well, the first thing is the actual capacity. Remember, it's advertised to have 2000 watt hours, and we only pulled 1500, so 75% of the advertised capacity is not a good number. I'd love to see that improved. The other thing that can be improved is the actual solar charge controller. If you're using this in a backup situation and you want it to run more than 500 watts, the battery is going to be dropping down. So a power station this big, I'd love to see 800 to 900 or 1000 watts of solar charging input so that you could actually run that load consistently throughout the day, and then you'd have enough power to get you through the night. Now, another little nitpicky thing is just the inverter. I'd love to see 120 volts versus 110 volts is what it has. So there you go, the pros and cons about this power station. Now, it is a budget power station, so it's gonna have a few quirks and things that could be improved on, but for the price, I do feel it's a good option. Now, I do have a discount code that FFpower did provide to you guys, my viewers, down in the video description to drop the price, I believe 9% off the already sale price. So if you are interested in picking up this power station, you can get an even better price. Now, I'd love to hear your guys' thoughts on this power station. Is it one that you go out and buy, or would you rather purchase something else? Throw a comment down below, let me know what you guys think. Now, if you guys like this video, please give me a thumbs up, and if you like the content, I invite you guys to subscribe to the channel so you guys don't miss any future videos. Because in my channel, we talk about solar panels, power station, batteries, and how it all works together. So I know if you guys like that stuff, you're gonna like my future videos. Anyway, guys, thank you so much for watching. I appreciate you sticking out to the end of the video, and hopefully we'll see you guys in the next one.